So welcome everybody to our wonderful afternoon workshop focusing on planetary boundaries with Professor Will Steffen very kindly sharing a couple of hours with us so that we can get an in-depth understanding of how the planetary boundaries concept was developed and what it means and how it's being downscaled and used by people around the world and in Australia. For those who don't know me, my name is Michelle Maloney. I'm the co-founder and convener of the Australian Earth Laws Alliance. Today, in a moment, I'll give an acknowledgement of country and introduce the broader Planetary Boundaries series. The program for the day is fairly simple, or the afternoon. Will very kindly give about a half-hour talk, then we'll have about half an hour for Q&A, and then another half-hour talk or presentation, followed by another half hour or longer for discussion and questions. But before we begin with just admitting people, before I introduce Will and invite him to begin, just wanted to share this beautiful photo. I'm speaking to you today from the beautiful Brisbane on the land of the Yagara and Turrbal peoples, and this photo is of the water lilies at the Nudgee waterholes. And in the local language, Nudgee means black duck. And another suburb nearby is Nunda, which is waterhole. So in the local language, we're actually looking at an image of Nudgee Nunda, which is about a 10-minute walk from my house, which I always like to acknowledge country, elders past and present, the incredible knowledge systems of the people who, the first peoples of Australia. And I also acknowledge my ancestry as part of the English-Irish colonising project that came to Australia, and my lifelong commitment to being, I guess, part of a decolonising agenda, how we can all become good friends and allies and good Aussies looking after this amazing continent that we live on. I often acknowledge where I grew up. I grew up out in the middle of Queensland in desert country on the Inangai land.
Hello, how are you?
And can everyone please mute yourselves? There's a few folks who just joined us and we can hear you. If you could please mute, that would be great. So I always like to acknowledge where I grew up and where I live now. And just to remind folks, I know a lot of you were on our call yesterday, so I'm not going to give a full presentation about AILA or our work, but I just wanted to let you know that the Australian Earth Laws Alliance was built from the grassroots up, and we're all a bunch of volunteers. Since 2012, we've been working really hard to bring together a range of programs to increase the understanding and practical implementation of Earth-centered governance. And by governance, we mean those big underpinning structures and institutions and values, the way our society is the mainstream society is built upon the kind of colonizing forces of European law and economics and westernized education. We're very interested in shifting some of our systems from a human-centered, growth-oriented, and often destructive to the living world focus back towards an earth-centered worldview, a more compassionate, socially just, and certainly earth-centered way of being. We're focused on systems change, and although we were created originally by a group of lawyers and governance folks, we are now a rather wonderful network of thousands of people with around 25 professional and student volunteers from law, economics, history, anthropology, the arts, education, and we all chip in together to work on a whole range of really fun and important projects, including the project that I'm particularly passionate about, which is how do we find ways, new ways to help industrialized societies change the way we live, work and play so that we can live within our ecological limits. And it's with that in mind that we've been running our Planetary Boundaries series. Yesterday we had an introductory workshop with, if anyone on this call I'm sure would agree, was quite brilliant. We had Ian Lowe, Will Steffen, Holger Hoff from Germany, Ross Williams as a Bindle juryman talking about traditional knowledge in Australia, Catherine Trebek talking about planetary boundaries and donut economics, and several other speakers and myself all talking about this sort of introduction to this amazing concept that we're going to invite Will to talk about more today. And the only other thing I'll do is a quick plug. Sorry, we also had Gethin Morgan speaking amazing history of the development of the scientific classification of country in Australia, and why our bioregions are such an interesting and informative and powerful way, particularly for non-Indigenous people, to start their conversation and relationship into country if they haven't already started to develop that relationship. I've already talked about why we're interested in planetary boundaries. I personally came across the concept of planetary boundaries back in 2013 when I was working with the rather fabulous Professor Brendan Mackey, and I found the planetary boundaries concept as a really fantastic knowledge system in Western science that can help inform particularly industrialized folks about these outer limits, and a really interesting way to rethink sustainable boundaries for the work that we do. And that's the final image I'll share, which is the work we do is very interesting in how we shift our governance systems from a human-centered focus to the earth-centered worldview that we personally believe is a beautiful way to live, but it offers some significant challenges to the systems that we live within. But I will now stop sharing. And I guess I just wanted to extend an invitation. If anybody is interested in this longer term work that Ayla is doing, please do connect with us. We've already heard from a number of folks from yesterday's workshop. I'm really excited about connecting with people into the future. I am not what you've joined up today to hear from. Will Steffen is. So without taking up more time, Will, I think I've already made you a co-host with share screen. So if you'd like to have a go at that. I'm sure many of you know Will Steffen already. When I first came across Will's work, he was then at ANU and on the Climate Council. He's now with many other groups, including the Stockholm Resilience Centre, and I'm sure he can tell you a bit more about himself. And I am, without gushing, truly grateful and thrilled to have Will share with us this afternoon. So hand it over to you, Will. Thank you so much for joining us.
Thanks so much, Michelle. Hopefully you can all see the introductory slide and hear me all right now.
Yes, we can hear you.
Fantastic. Thanks so much. Well, I'm sitting now in Canberra, where I've lived for the last 43 years. So I come from Ngunnawal country, the traditional owners of this beautiful part of Australia, not quite as tropical and beautiful as the scene that Michelle showed from southeast Queensland, but we have our own beauty in terms of the hills, the snow-topped peaks south of Canberra, and the rolling high plains up here. And it's a beautiful city to live in. We have some big nature parks right in the middle. I can walk to a mountain nature reserve that has wallabies, roos, any number of beautiful parrots. So it's a glimpse of what Ngunnawal country was like before we got here. But I want to move up now before I get back down to Ngunnawal and other country and talk about planet Earth in its own right. So as Michelle introduced, there is a concept now to help us, sort of a guidance system to say, how do we live sustainably on the planet as a whole? This idea of planetary boundaries. So the first half hour, I'm going to give you where the scientific foundation for this whole idea came from. Well, there are just 3 points to remember about what the planetary boundaries really is based on. First of all, the Holocene is the only state of the Earth system that we know for certain can support complex human civilizations. Second of all, human activities are now so pervasive and so disruptive that we are driving the Earth system away from the Holocene. In fact, we've already left the Holocene and we're in a new epoch called the Anthropocene. But thirdly, then, the planetary boundaries are a scientifically based framework for defining what we call a Holocene-like state of the Earth system. In other words, how can we return or stabilize the Earth in something that might resemble the Holocene? So
Will, I'm sorry to interrupt, just letting you know there's a lot of interference coming from when you touch your keyboard. It wasn't like this yesterday, so
okay.
Just letting you know, perhaps just be a little careful.
Okay.
Sorry, Will.
Right. Okay. So it's so the idea of the planetary boundaries scientifically is based on the observation that our planet is a single system. So okay. So now it's not shifting.
I think if you click on your screen, yeah, is that okay?
There we go.
Yeah.
Yeah, so if we look back at the history of the Earth system, we can do this via ice core data. This data here goes back, this is 400,000 years in the past, and it encompasses the entire time that humans have been on the planet from about 250,000 years ago. But you can see this is a temperature record, and you can see the Earth oscillating between short warm periods and long jagged ice ages in between. But the important point for us is that agriculture, more complex societies, villages, cities, and so on, only developed in the last 10,000 years, which is this warm period that we do call the Holocene. So this is really the sweet spot for humanity. It's the only one that's really allowed us to develop the types of societies that we have today and many of the societies we had leading up to today. So let's see if I can get that. So if we look at the last 100,000 years of Earth history in a little bit more detail, here we see the most recent ice age. And here we see the 11,700 years of the Holocene, where we started to develop agriculture, villages, cities, and so on. So our reference point in terms of temperature is a Holocene average, which we set at 0. And we can map on to this chart what human history looks like, including migration out of Africa. Indigenous Australians actually should be back further on this. This was done by Europeans, as you might guess from the great European civilizations that appear a few thousand years ago. We would have a little bit different take on this from an Australian perspective. But again, the point I want to make here is this is an unusually warm, stable state of the Earth system in its recent past. And that's, as I said, what we call the Holocene. But now when we look what's happening in terms of the contemporary time period from about the middle of the 19th century to the present, here we see temperature records of Earth's average surface temperature. And you see going out to 2000, actually this is a little bit, yeah, it's about right, about 2019, you can see a very strong increase in temperature, particularly since about the middle of the last century. We're now sitting at about 1.2 degrees above the pre-industrial average. But the most important way to look at this, in my view, is to take a long-term perspective by going back 2,000 years. So now we're looking at the last 2,000 years of the Holocene. And we have a pretty good idea of what temperature naturally did during the last 2,000 years. And you can see warm periods, colder periods. Here you see a long cooler period called the Little Ice Age. And here you have a period which actually doesn't show up globally, called the medieval warm period. It was only warm in the northern hemisphere. It was actually somewhat cooler in the southern hemisphere during the medieval period. The important point here is that this is the last century or so put on the same scale in tenths of a degree over here. So you can see how enormous the influence is of human activities on the Earth's climate when you look at it from a long-term perspective. This is why we're seeing massive bushfires in Australia. This is why we're seeing the bleaching of the Great Barrier Reef. This is why we're seeing impacts in the natural world all around the planet. The natural world is adapted to this climate. It cannot handle the climate we're seeing there. But we can also look at direct human pressure on the biosphere, which is also very important when you consider the definition of the Anthropocene. So there's a very important assessment done last year, 2019, by the world's experts on natural ecosystems, the biosphere, and so on. And they came up with a number of headline conclusions from this assessment. One is that nature is declining globally at rates unprecedented in human history. In other words, when we look at our 250,000-year history, never have we seen the extreme rates of impacts that we have in the last century or so. About 1 million animal and plant species are now threatened with extinction, many within decades. This puts us at the beginning of the 6th great extinction event in Earth history. And the web of life on Earth is getting smaller and increasingly frayed. Putting these two together, the increase in temperature and the degradation of the biosphere, means we are destabilizing many important features of the Earth system. Some of them are large biomes, like the Amazon, like the boreal forest, like coral reefs. Some of them are big ice features on the planet, like Greenland and Antarctica. And others are circulation systems, like the jet stream in the northern hemisphere or the ocean circulation in the North Atlantic. And these are subject to tipping behavior. In other words, if we push these systems too hard, they will flip to another state, sometimes rapidly, sometimes slowly. But they are connected like a row of dominoes. So the concern we have here is that if we start tipping these features of the Earth system, we will lose control of the trajectory and it will move to a very different state of the system. So the IPCC has assessed how vulnerable these are, and they say that there is already a moderate risk of what they call large-scale singular events, i.e. tipping points, at 1 degree, which is where we are now. And we already see some activity on some of these tipping points. But that risk goes to a moderate high level at 2.5 degrees. And so we did an assessment late last year, this is published about 6-7 months ago, of what we see in some of these tipping elements. And you can see here that in the small print below the name of the tipping element, these are observations that we see that already at about 1.2 degrees warming, we are seeing a lot of change in these tipping elements. And in each case, there are 9 of them here, they are moving in the direction of the tipping point itself. So we're clearly entering dangerous territory. We made a comment in that paper, if damaging tipping cascades can occur and a global tipping point cannot be ruled out, then this is an existential threat to civilization. No amount of economic cost-benefit analysis is going to help us. And we made a little landscape diagram, landscape cartoon to indicate where we are. So those are the ice ages I showed you before in that first graph. There are those short warm periods in between. And the Holocene is this nice little valley, stable state, very good for humans, and we've enjoyed it for the last nearly 12,000 years. But our activities already have pushed us out into a warmer state. It's a very shallow valley, very unstable, and we don't know where we're going. This is the fork in the road that we're probably facing in this decade, that if we continue on the way we are now, we are headed through these tipping points, through emissions of biosphere degradation, toward this tipping cascade, what we call here a planetary threshold. So these intrinsic feedbacks may take us beyond a point of no return, where we are committed to go into another state of the Earth system, which is much hotter and potentially stable for millions of years. But the point is that we have a choice, and that by really enhancing Earth system stewardship, taking our pressure off the planet, we may have a chance of parking the Earth in what we call stabilized Earth. Not really a natural state of the Earth system, but one that we will have to manage, or I should say manage ourselves, to keep the Earth in this state. This is where the planetary boundaries actually come into play. So the idea here is that this is the glacial interglacial cycling. This is the temperature spike at the end of the Holocene. That's the tipping cascade. And this is the planetary boundaries. The whole reason we invented or created the planetary boundaries was to say, we need to do more than wave our hands about a stabilized Earth. We need to actually define what that system looks like and what are the limits to the human perturbation, human pressures on the Earth system to give us a chance to stabilize it and have a planet we can live on. So let me focus now on more detail on where this actually came from. As you can see, we tried to boil down the entire Earth system into 9 different processes. You can read what they are. The idea is that we want to have what we call a safe operating space. So we want to have limits to how far humans can push these systems out from the stable state. So each of these radii coming out represent values of control variables that define how far we're tracking out away from the safe operating space. So the screen space, by the way, is not the Holocene. It's actually beyond the Holocene, but we think it is stable and has Holocene-like conditions. Outside the zone of high risk, we know we're in really deep trouble and that we're probably unconditionally committed toward hothouse Earth. But there's a zone of uncertainty in between where the risk increases the further we transgress the planetary boundaries. And you can see that we've color-coded where we are today on these boundaries. I'll come back to that, but that's the basic framework. We can also map it onto what we call a systems diagram of the Earth system. You don't need to understand this in any detail except to say that there is a green biosphere, there is a blue geosphere, and there's a yellow anthroposphere, the human side of things. And you can see through these arrows that they are all interacting to create a single Earth system. So this is what it looks like in 2020. And we can map the planetary boundaries onto this. So 4 of the boundaries are related to what we call the geosphere. They're climate change, stratospheric ozone, atmospheric aerosols, and ocean acidification. 2 of them map onto the biosphere. Biosphere integrity, the integrity of the entire biosphere, and land system change, which is the most important part of the biosphere that humans are changing. And then we have an important one for the anthroposphere. This is novel entities. This is new stuff like chemicals, plastics, radioactive materials, electromagnetic radiation associated with our digital world. These are all novel entities that we're pouring into the Earth system. And we have a couple of them that are really strongly focused on interactions. Biogeochemical cycles, the cycling of compounds like carbon, nitrogen, and phosphorus through the entire Earth system. And freshwater use, which moves through this entire system. So that's how the planetary boundaries maps onto the Earth system as a whole. Now, the conceptual framework was set up like this. Again, we have a green zone, safe operating space. We have a yellow zone where we know risks are increasing, and we have a red zone where we know we're in deep trouble. But there are 2 different types of processes that form the planetary boundaries or underpin the planetary boundaries. Some of them have tipping points. In other words, they appear to be stable until they hit a critical point somewhere in here where they tip. Those are some of the tipping elements that I talked to you about a little bit earlier. And they move to a different state on the other side. In other words, they've tipped into a stable state, but one that is very, very different from the Holocene. Now, it's important to note that we do not set the planetary boundary where we think the threshold is. We set it upstream of the threshold. And this gives us a safety margin to really lower the odds that we will cross the threshold. That's because we don't know precisely where thresholds lie. For example, for the Amazon basin, and I'll talk about that in the second session this afternoon. So the planetary boundary is set upstream of the threshold to give us the best possible chance of not crossing the threshold. But not all of the Earth system processes that have planetary boundaries actually behave in this nonlinear way. Some of them simply degrade, and we think biosphere integrity is probably a good example of that, where there's no known threshold. But yet we can say that at some point, we're starting to degrade how the biosphere is operating, and that you can see a somewhat larger yellow zone, and we know if we really degrade to a large degree, it will cease functioning in the way it's required to keep a stable Earth system. So this is how we set the planetary boundaries. They tend to be somewhat conservative because we want to make sure that we are keeping the Earth in a stable, safe operating condition for humanity and for a lot of the other creatures that we share the planet with. Here's an example of how we can map out at subglobal scales what some of these planetary boundaries look like. We use mean species abundance here as a surrogate indicator for biosphere integrity. I'll talk again a bit more about that because we are in the process of revising what the control variable might be. But when you see the red zone are zones where the planetary boundary has been transgressed, the green where it has not been transgressed, and the yellow where we're somewhere in this zone of uncertainty moving toward transgression. You can see a common pattern. Large agricultural zones around the planet are where most of the transgression has occurred. The areas that are in good shape, in other words, well within the safe operating space, are those that are too cold for humanity, here and here, or too dry for humanity, here and here. And there are only a few left, like the Amazon basin, some parts of the Central African rainforest, and actually not much is left in Southeast Asian rainforests. So basically what we're saying here is that one of the biggest drivers of changes in biosphere integrity has been the agricultural sector. And that's the one that we really need to work on in terms of the biosphere. When we look at freshwater use, again, what you see is many of the major rivers around the world, like the Indus and the Ganges rivers, the great Chinese rivers here, less so the Mekong, but most of the European rivers. Here's the Colorado River in North America, and so on. Many of these are now in the high risk zone in terms of human modification of river flow, through damming, water offtake, and so on. And if you go down here, the Murray-Darling Basin is also in that zone. The last large river, in fact, the biggest one on the planet, which still operates in reasonably natural condition, is the Amazon, although that's in the process of being changed as well. So these two give you good examples of how we can take planetary boundaries, and the average position of the boundary is an aggregate of what we see at smaller scales. So we'll get back to this, as this is where the scaling issue actually does become important. In terms of the biogeochemical flows of phosphorus, nitrogen, and so on, here we can look at application of fertilizer, nitrogen to soils. Again, it's the big agricultural zones that we see where the boundary is being transgressed. The same is true for phosphorus. Here's phosphorus, although there are larger zones that are being transgressed with the phosphorus boundary. Interestingly, Australian agriculture is not nearly as intensive as those in North America, Europe, the Indo-Gangetic Plain, and Eastern Asia. But we start to see yellow appearing in Southeast WA, in parts of Southeastern Australia. So there's a common, I think, theme coming through here. And that is when you look at the land-based planetary boundaries, we're talking about freshwater use, biosphere integrity, biogeochemical flows, and so on. It is really the large, intensive agricultural zones around the planet, which are really the hotspots of where we are transgressing these boundaries. One of the things in terms of the fundamental scientific framework of the boundaries, and this really has important implications for the application of the boundaries, is that we have, for simplicity's sake, ignored interactions between the boundaries. And we know that this is not the way they actually operate. The Earth is one integrated system. These boundaries interact with each other. And we're only now coming to grips scientifically with how we might be able to deal with this. So basically, the next iteration of the boundary framework will have more emphasis on interactions between the planetary boundaries. Now, we've done a very first, very simple analysis of what interactions might look like. It was led by Steve Lade, who is jointly employed by the ANU in Canberra and the Stockholm Resilience Center, and a group of us associated with the PB framework. And you see Holger Hoff's name here as well, and you'll hear more from Holger about applications of the planetary boundaries. I'm not going to go into detail, but I will make one point, is that we did look at the first level of boundary interactions. It got complicated fast, as you can see from this diagram. What came out of this is exactly what we thought. There are two boundaries that are really core boundaries: climate change and biosphere integrity. They are connected more tightly to many of the other boundaries. And we see this here when we have this diagram of where you see the strength of the interactions. But to make a long story short, when we turn all the interactions on, the safe operating space shrinks. Not a whole lot, except for biosphere integrity, and we've got to check what we've done here. But in most cases, that red line is without interactions. The gray wedges are with interactions, and you see the boundaries shrink a little bit. Intriguingly, one of them actually increases. And you might ask, why is freshwater use, why is the boundary actually increased? That's because when we violate or transgress the climate change boundary, we actually increase rainfall in general around the planet because we're intensifying the hydrological cycle. So that's counterintuitive, but in fact, it's scientifically accurate. So it's going to be very important in the future that we do a better job of mapping how these interactions actually change the safe operating space. Okay, so I'm going to conclude this quick overview of the science behind this by saying that we are now undertaking what we call PB 3.0. So the first planetary boundaries paper appeared in 2009. It was led by Johan Rockström. It was his idea originally. So next year we're going to do the second major update, the first one appearing in 2015. What are the major changes? We're going to quantify the remaining planetary boundaries. There are two of them that we have not quantified: novel entities and aerosol loading. They will be quantified for the first time. We can already tell you novel entities will be at least in the yellow and probably in the red, so it will be transgressed. We're going to update the biosphere integrity boundary. That's a difficult one. It's a very complex one. We'll probably change the control variable for that. We'll emphasize more on planetary boundary interactions, as I've just mentioned, and we will stress test the boundary framework using an Earth system model developed at Potsdam that is capable now of checking, is this framework really realistic in terms of keeping the Earth system in a Holocene-like state. So what about the biosphere integrity boundary? This is that graph I showed you before, again, mapping pretty much onto agricultural zones. But we can look at some other ones. This is called the Biosphere Intactness Index. This is actually a sort of qualitative assessment done by experts in the field, where they, again, color code, where the blue here is where the biosphere is pretty much intact, grading on toward orange and deeper orange, where we have transgressed biosphere intactness. Notice that when ecologists make this sort of assessment, we get much more human impact around the planet. Much of Australia now is impacted by human activity in addition to agriculture. And we see larger zones in North America, more of South America, and so on. So we've set the Biosphere Intactness Index somewhere up here around 80 to 90%. So most of these deep orange areas around the world are now where the biosphere is significantly degraded, well beyond the safe operating space. But another way we're looking at this is human appropriation of net primary productivity, which we think is a really good, more scientifically based approach, because this maps onto how much of the net productivity of the biosphere is left for the biosphere itself to maintain its functions. So these areas now, which are deeper colored, again, orange tending toward black, is where humans have taken, you can see 40, 50, 60, 70% of the output of nature and turned it into output for humans, i.e. it's mainly through agriculture, but through other activities as well. And notice that nature has basically been wiped out in the Indian subcontinent, heavily modified in Europe, Eastern North America, East Asia, and so on. And again, this maps now not just onto agriculture, but to where human population and human economic activity is occurring. It's likely we will use something like this as our control variable for the biosphere integrity in Planetary Boundary 3.0. The reason being is we can map on biogeochemical cycle, water cycling onto NPP. It's a good indicator for how the biosphere is actually functioning. Updating the freshwater planetary boundary. This is getting very complex. I'm not going to go through this in any detail other than to tell you that the water experts have dissected this boundary in great detail and gone through a number of sub-boundaries. And we're grappling with the fact that we don't want to let this framework get too complex or it'll be unwieldy in terms of applying, but we do want to get the underlying science sorted out. So what are the outcomes of our PB 3.0? We haven't, this is work in progress, but what we can say now is it is likely that 7 of the 9 planetary boundaries have been transgressed. That means we are well outside of a Holocene-like state. We are deeper and deeper into the Anthropocene. And both or all 3, if novel entities become a 3rd core boundary, which they might, then all 3 of the core boundaries have been transgressed. So that tells us that we are, again, in a difficult situation, and that we have to really develop a regenerative economy if we're going to get back into a safe operating space. It's not good enough simply to take the current pressure off the Earth system. We have to have a different economy, different society that's built around regeneration rather than exploitation. So this, I think, cartoon captures it really well. This comes from the Canberra Times, my hometown newspaper, David Pope, and he's done a beautiful job, I think, of putting in a cartoon framework where we are today. This really does summarize where humanity is going. We're whipping away at an increasing rate, driving the Earth system out of the Holocene. And I like this statement. Thank goodness for all electronic gadgets. It's not only keeping the kids occupied, it's keeping all of humanity occupied. Every time I walk around the streets of Canberra and seeing that 90% of the people have their heads down looking at their phones, I know that we've got something terribly wrong in terms of humanity's interaction with the rest of the planet. So I'm going to stop there, Michelle. That's a quick scientific background for where the planetary boundaries came from and where they are headed. So I think we have some time now for some questions.
Yes, thank you so much, Will. Perhaps you could keep your share screen on. I was going to say, in case people have particular questions. No, it's okay. We can bring it up if we need it. Jody has already jumped in with a question, and she's asking, with Planetary Boundaries 3.0, when you say human, are you specifically meaning the last 200 years and only industrial era humans, or is it open-ended or more open?
Yeah, it's a really, really good question. No, we're talking about in terms of the transgression of the boundaries. Most of these boundaries would not have been transgressed in the early 20th century. So most of the transgressions occurred with what we call a great acceleration of human activity, which is from about mid-20th century onwards. So one of the biggest, I think, critiques of the Anthropocene concept and the planetary boundaries is the humanity as a whole idea. It has really been the industrialized 20% of humanity that's driven the Earth system out of the Holocene. Having said that, with this rapidly globalizing system that we have now, as we go into the 21st century, the way of life of the 20% of us in the OECD countries is spreading to other parts of the world as they develop in similar ways to the way we have developed. Increasingly, we can start to talk about humanity as a whole, bearing in mind, though, that there's still large fractions of the human population which have low income levels, low resource usage levels, and is certainly not the problem in terms of transgressing the planetary boundaries. So I just want to make that point. It's a very good point. There are enormous inequalities and inequities in human societies, and they are really part of the challenge that we face. When you look at this from an Earth system science point of view, the way I like to put it is, we have enormous problems of many shapes and complexities. But if you want to boil it down to something you can manage to 3 problems, it's this. We are changing the energy balance at the Earth system, at the surface of the Earth system. That's climate change. Number 2, we are vastly degrading the biosphere. In other words, we are changing the web of life. Number 3, we are actually increasing inequalities amongst human societies. And that has deleterious effects on our health, on our psychological health, and so on our societal integrity, and so on. So you can boil it down to those 3. Those are the 3 we got to solve, and fortunately, it's probably the same underlying driver of all 3 of those changes that we need to address. Very good question. Yeah.
Thank you, Will. Sophia has asked, and I think we talked a bit about this yesterday, but have these studies been presented to government bodies and policymakers, knowing that we've transgressed 7 out of 9 boundaries has shook me in my seat? I'm wondering how our lawmakers and government officers are reacting. I think you might be even more shaken in your seat, Sophia, to hear what Will's about to say about the Australian government's interest in planetary boundaries.
Yeah, we haven't gotten anywhere with the Australian government. Holger Hoff will be able to tell you a lot more. Holger and colleagues have been working with governments in Europe. I know that Sweden, Switzerland, and maybe a couple of others have, at a high level, examined the planetary boundaries and tried to track what their contributions are to transgressing the boundaries. As I'll say in the second presentation today, it gets tricky because of the globalized economic system to track really what's driving the transgression of these boundaries. But nevertheless, it's important that we start looking at smaller scales to see where our pressures are really coming from. My general comment is, if you look at certainly the OECD countries, and if you look at the English-speaking world, I think there's been very little traction at governmental level, certainly not with our government. I think there's been some interest in New Zealand, which you might expect with the progressive government that New Zealand has at the moment. No interest whatsoever in the United States at the governmental level. That's not surprising. Not much interest in the UK. So it's mainly the progressive governments of Europe, plus countries like Bhutan and Costa Rica, which are outliers in that they are countries that are generating well-being economies and are very much interested in indicators that can help them assess how they're tracking.
Thank you, Will. Will, we heard a short talk, a 30-minute talk from Holger Hoff yesterday, and I've invited him to come back and join us for a longer webinar and masterclass over the coming month or 2. So for those who weren't in the workshop yesterday, Holger who Will has referred to, has been doing some amazing work on downscaling the planetary boundaries to national and company organization levels. And again, this is an area of work that Ayla is engaged in. So if you're interested or you're working on it, please stay connected. There's a couple more questions, Will. I'm going to jump in and ask one myself.
Sure.
And I'm not sure if you'll cover this perhaps in your second presentation. From an Australian point of view, we're certainly aware that our governments are not engaging with these important concepts and their policies not driven by these important issues. But from the Australian context, if not now, later, could you suggest any other groups and organisations to connect with in Australia so that we can forge forward together, pushing some of the planetary boundaries messaging and ideas into the policy frameworks?
That's a good question. It's a difficult one for me to answer because virtually all of my planetary boundaries work is done with colleagues in Sweden, Denmark, and Germany. And that's where I spend most of my time also talking to people who are applying it. It really hasn't taken hold here. I think Ayla is going to be you're going to be the spearhead, hopefully.
I will if I can, with any breath
Yes.
in my body, absolutely.
Yeah, so I think, yeah, it's hopefully we can make this a lot more visible, and I'm happy to give talks around Australia on this. I do some talks on planetary boundaries, mainly to academic groups and not to groups who are trying to bridge the academia real world applications of them.
Okay, well, thank you, Will. And again, for folks who weren't part of our call yesterday, our workshop yesterday, the exciting thing was we heard from Catherine Trebek, who's part of the Wellbeing Economy Alliance, who Ayla and Nina are members of, and they are involved with the donor economics ideas which fit inside planetary boundaries. So we'll probably talk a bit more later today about some of the practical implications of planetary boundaries, and certainly Ayla and the New Economy Network are engaging as heavily as we can into those spaces. But thank you, Will, for indulging me as the moderator, but also the person with the question. Lots of good questions here. Oh, sorry, Kathy actually said, wow, it's so sad. What will be the mental health costs? I'm not sure if Will wants to comment on that, but it's certainly the social issues around environmental decline are pretty profound, aren't they, Will?
They are, and I want to make one point here is the health and social issues of inequality are phenomenal. There's some beautiful work done by some British epidemiologists, Kate Pickett and Richard Wilkinson, who show quite clearly that for those countries, and the mainly English-speaking countries that have the largest disparity in income between the wealthy and the most of the rest of us, they also have the largest social problems. And these are social problems not to deal with poverty. They're problems like obesity, social breakdown, mental illness, and so on. And they correlate exceptionally strongly with income inequality. So you might guess the countries that have the lowest inequality, which are Japan, Sweden, Denmark, and Norway, have the best social outcomes. And that can also maps on, in general, not quite as strongly, but in general on deleterious impacts on the environment as well. So this whole package of problems of climate change, biosphere degradation, inequality, social issues, they're all bundled up with the same underlying economic political system.
Thank you, Will. I'll keep moving on with the questions. Tim asks a question which we may have touched on with the Australian political or policy context, but it's a great question. Is planetary boundaries thinking having a significant impact on global policy making yet?
Not really, but I actually think at the international level, it's gaining some interest. You're going to hear from Paulo Marguelis, I think in a week or two.
On the 5th of August, we have him as an evening seminar. Yep.
Make sure you listen to him. He has the most innovative idea from a legal perspective, and he's making great inroads internationally. In fact, he's really gotten some attention from the UN, partly because the Secretary General's from Portugal, and there's a bit of a Portuguese mafia here. But anyway, I'll be on at 11 o'clock tonight talking with some UN people about planetary boundaries and Earth system science. Yes, so I think at the international level, there's a real appetite now with the SDGs and the fact that, you know, we're running toward 2030 now, and we need a framework, an overarching framework for how we interact, how we relate to our planetary environment. And this is, and the missing link has been not only conceptual, it's been legal. And this is where Paolo comes in. So I really urge you, he will answer that question really, really well and much better than I can answer it.
Thank you, Will. Yes, 5th of August, but do check our landing page for all of our Planetary Boundaries events. Very excited to be able to hear from him. Mark has asked, Will, when you talk about a control variable, are you implying that we have control type models and equations, etc., for these systems?
That's a good question. We don't go to the mathematical control variable or engineering control variable. We don't go to that level, but it's that conceptual level to say, what is the major variable or variables in some case that actually control where this process is going? Climate change is an easy one because although it's an extremely complex question, really a very fundamental control variable is the concentration of CO2 in the atmosphere. That acts as a thermostat for Earth's surface. And we can see it back in the paleo records back hundreds and millions of years ago. So, and that's one that we have a direct lever on through fossil fuel emissions and land use change. Some of the other ones, it gets tricky, like what should be the control variable for freshwater use? Is it the amount of water that we take out? Is it the amount of water that we let flow to the sea? That sort of thing. So, and biosphere integrity, what should the control variable be there? And that gets really tricky because there it's not a direct correlation between one variable and how the biosphere responds. It's much more complex. So the concept is as you say, but the practical application isn't as neat as in an engineering sense.
We've got some wonderful questions here. They're branching across science, mental health. I sympathise with Alice's question because she starts it with, as a non-scientist, which I can relate to. This is a great question about the communication around planetary boundaries and how we can communicate it as non-scientists. But I'll read the question, Will. As a non-scientist, one of the things I struggle with is understanding and describing the interactions between planetary boundaries and the nature of the Earth system as a whole. Even though the concept is intuitive, it's hard sometimes to get beyond a generalization of everything is connected. Could you talk a bit more about how the Earth system science community is approaching the task of understanding and measuring and communicating the interactions as part of PB3? Yeah,
and I think that's a really good question. And I think the point there is the Earth system acts as a single system. An analogy I like to use is is your own health and the planetary health. So if you look at a human being, we are an integrated system. In fact, there are a few metrics that doctors use. One is your body temperature, because being a mammal, we have a very well regulated body temperature. And there are other indicators that physicians use. But when you look at us, we have subsystems, don't we? We have a digestive system, we have a nervous system, we have other systems too that make us up. But they all interact, and the result of that interaction is a human being with characteristics of us as a whole. Same with the Earth system. We have an ocean circulation system, we have an atmospheric circulation system, we have organs, we have the Amazon basin, we have coral reefs, we have things like this, and they do interact. What we as Earth system scientists have to do, though, is just like your physician, rather than get bogged down in the absolute complexity of the human body, physicians try to say, all right, if your temperature is going up, let's try to find out why. You know, do you have a liver infection or something like this? We're trying to assess the Earth system in the same way and say, look, what is the minimum number of organs and interactions that we can have to describe the Earth system before we get bogged down in complexity? And we argued this for a year or two at the beginning and came up with 9. And that's been debated. We've been criticized. Oh, you've missed this, or you can put these two together, and you probably could. But the point is, we are trying to do what your physician does, which is to say, all right, this is a very complex system, but we have to be able to understand the important parts of this system and how they're related, the ones that actually control how the overall system functions. That's what we're trying to do. So I don't know whether that answers the question, but that's really the best analogy I can use for a non-scientist is your own body and how you feel, how it operates, what a well-functioning, healthy human looks like, what a diseased human looks like, and how we try to assess what's happening if you're unwell, as the planet is now.
Mm. Thank you, Will. And it would be fair to say then, for the non-scientists, including me, that Planetary Boundaries isn't the first port of call to understand the details of planet Earth, but to, really it was driven by the need to identify where things are going wrong and how we can rectify that. The same as a doctor isn't interested in bits of you that are working, really. They're interested in working out when you're unwell.
Well, that was part of it. I mean, the motivation was we sensed that the Earth was unwell, and as planetary physicians, so to speak, the first step is compared to your own physician. Your own physician already knows an enormous amount about human physiology. We weren't anywhere near that level for the Earth. In fact, modern science had pretty much failed to understand the Earth as a system, because the reductionist mode of modern science is to pull pieces of it out and study them in great detail, holding everything else constant, which is a nonsense in a complex system. So our job was to try to say, we got to really go back fundamentally and say, what is the minimum way we can take Earth apart and understand how it operates as a system? We didn't want to get down into details of the Murray-Darling Basin or Ecosystem X in South America. We wanted to say, what's the minimum number of features and circulation systems that we need to know to understand the planet as a whole? Now, you can take the forests of Southeast Australia that burned horribly. That actually doesn't affect the Earth system very much. But if you really screw up the Amazon basin, which we're in the process of doing, that will. So that's the sort of metric we had to use. So, but obviously around Australia, it's the ocean circulation patterns which are really important. And if we screw up Southern Ocean circulation in some way, or the Indian Ocean dipole or something, that has global consequences. So it's trying to understand what really matters at the scale of the Earth. For example, in a human system, you can break your toe, but that's not really a big deal. I mean, I actually broke an ankle and walked out of the Southern Alps in New Zealand with a broken ankle and survived and so on. But if I puncture a lung, that's really, really serious. So your physician knows what is an ailment for sure, but is not life-threatening or doesn't threaten your overall health. So again, that's a good analogy. We need to understand what are the organs of the Earth and what are the major circulation systems that if you screw those up, the whole system is in trouble.
Thank you, Will. In fact, your mention of the oceans is a lovely segue for the next question. Genevieve has asked, said, as a scholar of the law of the sea and an Earth System Governance Research Fellow, ooh, very good, want to hear from you, Genevieve. I'm interested to learn how is work progressing on biosphere integrity indicators for the ocean biosphere. My research looks at Oceania, and the role of regional scale oceans governance architecture. What are your thoughts on the scales of governance and their connection to the urgency of global environmental change?
Yeah, that's a really good question. I should preface it by saying that the lead author for PB 3.0 is Catherine Richardson, who's a marine biologist. So she is making sure that the ocean gets more attention. After all, it's 70% of the Earth's surface. It does some enormous heavy lifting with the carbon cycle and so on. But its biosphere is very different from the land biosphere. The land biosphere, a lot of the action is actually bound up in living infrastructure, forests, trees, and so on. But in the ocean, it's the smaller organisms like the phytoplankton that actually do the heavy lifting in terms of cycling things. So we've got to come up with better metrics for understanding, if you like, the health of the marine biosphere. And it's going to look a bit different from the land. I don't think we're going to get a one-size-fits-all for the land and the marine systems because they are so different. But that raises an interesting point, is that as humans commandeer legally more and more of the ocean, like 200-kilometer economic zones and so on, what's left as common heritage for humanity is the bits that are left over. That's what Paolo is going to address. That's exactly the wrong way to look at it. And an integrated, well-functioning ocean is the heritage of all of us, not a single country. And that's the idea of the common home for humanity, using the planetary boundaries as the metric to say what's a well-functioning state of this common home. So there's going to be some interesting interactions between the existing framework of marine and sea law and the proposal for a common home for humanity. And part of that's going to hopefully be supported by better metrics for understanding how the ocean biosphere works and how much we are perturbing that system. It'll look different from land, that's all I can say. But PB 3.0 should do a better job than what we've done in the past.
Wonderful. Will, which part of 2021 is PB3 coming out, do you think? Or is
we can't, like all multi-authored papers, I can't predict that because we're a complex system ourselves interacting, and the emergent property, which is the paper, is going to be hard, which is going to be hard for us to predict when it's actually going to come out. But all we're saying is 2021. It's a big task.
Fair enough. I can barely imagine. So yeah, thanks, Will. Sophia has asked, who do you think needs to see Planetary Boundaries findings so that we can act on it? It's kind of linked to the policy question.
Well, I think every global leader around the planet needs to sit down and have a session on planetary boundaries. Because each leader, whether it's Scott Morrison or Trump or Boris Johnson or Stefan Löfven is the Prime Minister of Sweden, or whoever runs Bhutan, they have one thing in common. Their ultimate goal is to look after their population in their country and the health of their country and population, hopefully the health of their environment too. And that requires them to understand how they're all interlinked as a common global system. And unless they can do that in this hugely populated, rapidly economically integrating, globalizing system, if you don't understand the Earth system, we're going to fail at our most fundamental goal.
And in fact, Sophia had a second part to the question. Would writing to MPs be a useful course of action?
I think it always is. No matter how you think our democracy functions and whether it's flawed or not, or whether it's too much controlled by vested interests, nevertheless, it is much better than many other systems around the world. I can tell you that our democracy is far better than the one I came from 43 years ago, which is across the Pacific, which is now pretty much in trouble. So yes, I think it really does help. What I tell people is do whatever you're comfortable doing. Some people would join the Extinction Rebellion and get out on the streets. That's fine, so long as it's peaceful. Other people will will protest and so on in different ways. Students out protesting. Other people are uncomfortable, but will write to the MP, and that's also important too. They are responsive to that. They want to get reelected. They know that given enough pressure, if they can sense that their electorate is getting really concerned about something, they'll start to listen.
Thank you. Janet has commented, as a medical doctor and a scientist, I love the explanation about Earth system science, comparing it to the systems of the human body. So there you are. That's good. Comments about some universities are championing this thinking, including Melbourne Uni, at least in the Master of Environment. That's good to know, Tim. Tammy says, so is Monash. I'm in the Masters of Environment and Sustainability. Jody has just made a comment. Tipping points, connectivities on long-term and large scale, plus life as a driver of Earth evolution itself are key features of the Earth system and are a helpful summary and takeaway from teaching and learning perspectives.
Yeah, indeed. Good point.
Helen is asking, is human population considered only in the context of biodiversity?
No, well, it's as you saw in that diagram, the anthroposphere, which is our human populations, but everything else we do, how we interact, how we govern ourselves, what our economies are like, what technologies we use, what stuff we produce, that's part of the Earth system quite strongly. So it's certainly considered as an integral part of the Earth system. Part of that, of course, is the ultimate population numbers. But in fact, when you actually do the analysis, more important than the actual numbers of us around the planet are what our economic and technological systems are doing. And that's where the inequality issue comes in. That most of the impacts, I can say that when the last time we analyzed this in detail, which is a few years ago now, about 20% of the human population, that is the OECD countries, were responsible for 74% of global production and consumption. So there you go.
Thank you, Will. Margot has a long comment or question. Okay. Margot says, I note your comments relating the complicated variations, for example, measuring biosphere integrity and the translation of the planetary boundaries into practical goals is not a simple task. Do you envision the planetary boundaries supplementing or supporting substantial scientific force to the SDGs? Oh, this is great. Yes. My question too. What could the relationship be between SDGs and planetary boundaries?
The answer is it's already there.
Yep.
Planetary boundaries were woven into the SDGs from the beginning. Johan Rockström was the main link there. And of course, Johan, it was his original conceptual development of planetary boundaries. So they're not in there as 9 boundaries, but you can actually map reasonably directly where the 9 planetary boundaries go. So yes, they were part of the development of the SDGs. And I actually like it as being interwoven into them rather than something separate. So yes, they are in there.
Can I ask a further question, Will? The SDGs are often critiqued as being still supportive of a human growth or development.
Yes.
What would you say to that criticism, and how could folks like us who are trying to get people to think about the growth mentality and that connection between PBs and SDGs and other acronyms?
Yes, I fully agree with that. There is one of the 17 SDGs, which is on economic growth. That was put in there at the insistence of many government economists and political leaders. A lot of us actually objected, but we got overridden. And in the end, they wanted to get universal approval for the SDGs. So as usual, there had to be some compromises in the system. And that is a big compromise in the system. So in my view, that's actually incompatible with most of the other SDGs.
Yes, very interesting. Thank you, Will, and thank you, Margot. Another question here from Janet. In regard to planetary boundaries and governance, how does Antarctica fit? Can Will and Michelle comment, please? Antarctica is unique in terms of biosystems, studies and geopolitics, and given it has to be shared between nation states, how do we care for this country, this place? Is it a country?
Yeah, look, that's one example where we at least have come close to getting things right in terms of nobody actually owns Antarctica. It hasn't been divvied up like the rest of the Earth, and actually a fair bit of the ocean now. It is somewhat of a common heritage for all humanity. Mind you, there is growing pressure to open up parts of it for mineral development and so on. That actually is a recurrent theme. And as you recall, Australia and France played a leadership role in blunting an earlier attempt to open up Antarctica to mineral development. But it is, if you like, a mini model of how a common home for humanity might work, in that there is a governance board which has as its main goal maintaining the integrity of Antarctica as a very interesting living system, as well as the biggest piece of ice on the planet.
Great question. We're coming towards the end of our questions, which means we might be able to give Will a bit of a breather. We might have a little break in a minute so he can have a cup of tea if he wants one.
A good idea.
I'll throw a weird question at you, Will, because I have just been invited in the last week or two to speak at an event where a number of folks are interested in the moon. And I'll tell you the context and ask you a question. A lot of people are concerned that although for many decades, the space laws relating to the moon as like a no-go zone and the common heritage of humanity, they're worried that corporate movement into space is actually going to threaten the moon. And a lot of people have got their eyes on it for water and mineral mining. So my question to you, I was asked to speak in a session just looking at legal personhood for the moon. They've got space lawyers, and it's very unusual for an Earth-centered person to be talking about matters that are lunar. Do you guys in your planetary boundaries work factor in, I mean, if they mine the moon, they're going to mess up our gravity, aren't they? And they're going to mess up the oceans. Is this something you've ever had to think about, or am I just being a bit random?
No, we haven't thought about it, to be quite honest. We got our hands full with Earth before we think about it.
Exactly.
Off the top of my head, my very quick reaction would be we might be able to handle it with the within the present planetary boundaries framework by saying that anything we do there and try to relate it back to the Earth, we might even call it a novel entity and say it's bringing new stuff into the Earth system that wasn't in the Earth system before. We have a very broad view of novel entities. For example, our digital world, all this electromagnetic radiation that's being sent through the wireless systems is new stuff for the Earth system. We don't know how in the long term it's going to affect the Earth system, if at all. But these are novel entities that are created by humans. I presume the minerals on the moon would resemble or be identical to minerals on Earth, although I'm not sure about that. I really haven't studied the lunar environment. But I would certainly, the way we define the Earth system is it ends at the outer atmosphere. So anything you bring in from the outer atmosphere, from our definition of the Earth system, is a novel entity. And we could deal with it as such.
Okay. I might have another chat with you another day about, I'm seriously worried if they mine it, how that's going to affect our oceans and our tides. I don't know if that fits into the boundary of gravity.
I don't think it will, because it's the overall mass of the moon. And I think you're going to mine a hell of a lot of it before you're going to change the mass of it significantly.
Oh, that's good. I'm glad you told me that before I go on to a session and sound like a foolish person. So, Will, this is your masterclass. Would you like a 15-minute break to make a cup of tea, or would you just pass through?
No, yes, and then let's come back at 3:30 and do the second presentation.
That would be lovely. So if everyone is okay with that, I might actually get a cup of tea too. So I'm going to mute myself and turn the screen off for me. Will, you might like to mute yourself as well. I'll pause the recording. And if everyone would like to have a little break, we'll start at 3:30 p.m. Brisbane time. Thank you so much, Will. This has been fantastic. Back 15 minutes, folks. Okay, so again, thank you so much, Will. Really looking forward to the next session in our masterclass. Over to you.
Okay, thank you, Michelle, and I'll start my share screen again. See if we can get this to work. Right, hopefully you can see a very similar looking opening slide to the one last time. And now we're going to look at how do we actually apply this framework in terms of both the challenges that we face in terms of taking a framework which was designed for the planetary scale and trying to put it into operation, but also some opportunities that arise and how we can do things differently. Holger Hoff is going to talk a lot more in detail because he's had a lot more experience in actually applying the Planetary Boundaries framework. But let me try to start with some overarching challenges and principles. So first of all, the application challenge is that we based the Planetary Boundary framework on Earth as a single complex system, and we only deconvoluted it to the large ocean basin and large biome level, and nothing below that. It's not saying you can't, but it gets more complicated as you go down. And part of that is due to the fact that in some cases, there are nonlinear processes that connect scales between planetary and down to local and regional. So when you downscale, you can't just do it as a nice little arithmetic operation. You have to take into account that there are nonlinearities here. The other thing which I do want to mention is that because the planetary boundaries were designed to keep the Earth system in a Holocene-like state, a Holocene-like state does allow changes to environments at local and regional levels to some degree, and that doesn't disturb the state of the Earth system. But for many of us, we value our local environment very much for its own intrinsic reasons. And so often local and regional environmental regulations will actually be more stringent than what a downscaled planetary boundary would look like. So I've actually gotten into trouble before by saying, well, no, that wouldn't transgress a planetary boundary if you did X in region Y, but people were enraged because it would damage their local ecosystem. So bear in mind that local regional environmental regulations are often more stringent, which is good because that helps us respect the planetary boundary as well. And with a globalized world, who is responsible for what impact? And I'll get onto that in a moment. That's really important. Okay, so the downscaling challenge is, where do we downscale it to? Countries. It makes sense for a country like Australia because we're a continent. And it may make sense for the USA, for Russia, and a few others. But many countries like the Netherlands, for example, or Kiribati, it doesn't actually mean a whole lot for the Earth system. Subnational level, how far down do we go? Do we downscale it to companies and businesses? This to me is a really intriguing and important one. And Holger's done a lot of work on this. And I think this is something we really need to think about more carefully because these are such important players in how the Earth system operates. And can we even downscale it to individuals? So that's really what some of the challenges are. And the thing we need to bear in mind is as long as we don't neglect the need for system level analysis when we downscale. In other words, you're connected to something else all the time, no matter whether you're a business, a nation, or a region. So let's look at how we might approach actually applying some of these. So the two core boundaries up till now are biosphere integrity and climate change. Why do we define them as core boundaries? We do so because we think on their own, if disrupted or transgressed, they can change the state of the entire Earth system. And we see this in the geological past, where rapid or sudden changes in climate usher in a new geological epoch. We also see it with great extinction events, which change the integrity of the biosphere. They also change the state of the Earth system. The other boundaries feed into these and link up to them. So let's look at the first one in terms of downscaling, and that's climate change. This is one where I think we can do a good job of downscaling. In fact, we already do through assigning emission limits to various countries, to companies, to individuals, and so on. And we can do this because the control variable for climate change is CO2 concentration in the atmosphere. And the way we affect this is by emitting CO2 primarily through fossil fuel use. Another reason we can downscale this pretty well is a nice fortunate feature here of the Earth system, and that is that the temperature increase due to increased greenhouse gases is approximately linear or linearly related to the cumulative emissions of CO2. So therefore, we can actually downscale this rather nicely by saying, no matter how small your emissions are, they are adding to the cumulative emission that humanity puts into the air, and they are cumulatively adding to the temperature increase. Well, how do you do this in practice? Well, I was part of a nice project here in Canberra, I should say in the ACT, where we did exactly this. We said, all right, Canberra, if you can downscale the climate challenge in terms of emission reductions, what should the ACT do to be doing its part? So we didn't use a planetary boundary directly, we used the Paris Climate Agreement. So if you look at the lower one of 1.5 degrees, that's pretty close to a Holocene-like state of the Earth system. So like everyone else around the world, Canberra's emissions have been creeping up since 1990. And you can see these are observed emissions up until about 2010. And the ACT had an election in 2011, where one of the key issues was, what is Canberra going to do around climate change? And in fact, one of the campaigns was, Canberra needs to reduce its emissions by 40% by 2020 to do its fair share. And that was a tag called Canberra Loves 40. So that was picked up by the local Labour Party. They won the election, and much to their credit, they actually got to work and said, we're going to deliver on this. So they started rolling out from 2011 renewable energy in the territory and also in the surrounding region in terms of wind energy. And so this is what the emission profile looked like as we started this. It was a bit of an uptick here. But then this was the projection out to 2020. So this was made in 2015. So we had a big drop in only 5 years, but I'm pleased to say Canberra is here today. This is what our emission profile looks like. So we have dropped our emissions by 60% since the upper boundary here in 2000, should be about 2010, 11. but we've dropped it by 40% on the 1990 level, which was our target. What we've done now is we've actually now legislated an emission pathway that takes us to net zero by 2045. And we've actually legislated emission reductions along the way in terms of a fairly tight range. Those are the two curves. And if we deliver on this, and we're legally bound to do so, this would correspond to about a 1.8 degree temperature rise if everyone around the planet followed the same trajectory. So here's a good example of how you can downscale the budget. You can actually implement a carbon budget at a jurisdiction. Obviously, the ACT is not very big, but we're approaching 500,000 people. So it is scalable and it is doable, and you can do it without damaging your economy. So here's a good example of how we can downscale a planetary boundary, implement it, learn from it, and hopefully be able to replicate it. Let's now talk about biosphere integrity. This is a lot messier. It's a lot more complicated. The biosphere is, in my view, a lot more complex than the geosphere, and it's one that's much more challenging for us to apply planetary boundaries to. But I want to look at one of the major boundaries that feed into biosphere integrity, and that's this one, land system change. Because we are terrestrial creatures, and although we're enormously affecting the ocean, our early and primary disturbance to the Earth system is on land. So let's now look at how we might downscale a key land system change boundary and link it into biosphere integrity. So my example here is the Amazon rainforest, because when you look at land system change, we have a tighter boundary for the 3 big tropical forest zones than we have, for example, most of Australia. And that's because they play a more important role in the integrity of the biosphere. So we have a boundary of, have to think, I think it's 80 or 85% intactness of these large biomes for them to play their role. So some deforestation is allowed at the planetary scale, but not much. How do you downscale this to the Amazon basin? Well, first of all, you might say this is mainly Brazil and its surrounding countries' responsibility because they have jurisdiction in a national way, territorial way, over that area. So the bulk of the Amazon is in Brazil, but if we look at Brazil today with the Bolsonaro government, we see that we have big problems in terms of trying to implement a planetary boundary at that scale. And of course, Bolsonaro himself would laugh at the planetary boundaries framework and say, this is Brazilian territory, we're going to do what we want, and the rest of you can go lay eggs or whatever. But the problem is the Amazon is actually connected globally. So unlike the Australian fires, which put a lot of carbon into the atmosphere, but didn't directly affect the climate, deforesting Brazil will, because the deforestation of the Amazon basin actually affects global circulation patterns. It leads to cooler temperatures in Northern Africa and Southern Europe, but much warmer temperatures across Central and Eastern Asia. So this is interesting. This is not due to the CO2 emissions. This is due to changes in atmospheric circulation. So this piece of the terrestrial biosphere with biosphere integrity plays an integral role in atmospheric circulation. So therefore, it's far more than a Brazilian or South American issue. It is a global issue. And so this is why it's an important part of the biosphere integrity boundary. And we can go through great details of how this connection actually occurs in terms of weakening intertropical convergence zone, the subtropical jet, northward shift of baroclinicity, all these technical terms in terms of atmosphere. But this is all due to converting this forest into agricultural land or a grassland. So this is why it gets tricky. It is that the Amazon basin is important for all of us, particularly those that are directly affected by it. When we look at these tipping cascades in the Earth system that I talked about earlier, the Amazon basin is connected. So here's the connection here to the thermohaline circulation, Greenland ice sheet, and so on. And also, it does affect us too through the ENSO. So we know that El Niños are really difficult for Eastern Australia. We have severe droughts, but converting the Amazon rainforest to agricultural zone will affect ENSO behavior and probably lead to more intense El Nino phases. So we ourselves in Australia are affected by what Bolsonaro does. So that leads to the issue of who's responsible for the Amazon rainforest. It is a global issue. So how does this tipping element work? The other thing I should say is it's a tipping element that if you deforest too much of it, it's under its own dynamics going to convert largely into a grassland. It operates this way, is that the rainfall that keeps the Amazon rainforest, a lush rainforest, comes about 50% from the ocean. This is from the Atlantic Ocean, but 50% is internally recycled. So this is transpiration from trees up into the atmosphere. It condenses, the water vapor condenses and comes back down. So internal recycling provides half the rainfall for the Amazon basin. So climate change, change in ocean atmospheric circulation, driven by our greenhouse gas emissions and everyone else's, is already starting to reduce this branch of the rainfall. In other words, there's increased drought in the Amazon basin due to the fact that we are changing ocean circulation because of climate change. That's delivering somewhat less rainfall to the Amazon. And that leads to dieback and fire, and it converts the forest into a savanna. So if we lose too much rainfall from the ocean, that on its own would convert the Amazon into a dry forest or a savanna. But on top of that, we have deforestation, and that's where direct human impact comes in, conversion to cropland or pasture. This reduces the internal recycling of water because there's less evaporation from a pasture or a cropland, less water recycling. And of course, these two are acting together. It's a double whammy on the Amazon. So you have climate change and you have direct human deforestation. So we can make some estimates using some models of where this tipping point might lie. So deforestation alone, if we clear from 20, certainly up to 25% of that forest, we're likely to tip it, and it will go into a cropland or a pasture through fires and so on its own. Climate change alone, a 3 to 4 degree temperature rise, even with no deforestation, would probably flip the Amazon into a savanna. But if you put this together, deforestation and climate change, the Paris 2-degree target would reduce allowable deforestation to significantly less than 25%. And the Paris commitments, which would lead us to a 3-degree temperature rise, if we all lived up to our Paris commitments, which aren't enough for the target, these are the commitments governments have made, that would reduce allowable deforestation to near zero. So of course it's not near zero, or it's already approaching 15%, which means that if we violate the Paris commitments, the Amazon rainforest is largely gone. So this is what we face. So where do we stand now? Here you can see the pattern of deforestation. The green is the Amazon basin, or I should say the Brazilian part of the Amazon basin. And you can see these red areas of Rondônia and Mato Grosso is where a lot of the deforestation has occurred, some in Pará. But you can see it's being eaten away around the edges and along transport corridors. Matches very well to where the population is in Brazil and where it's expanding along these transport corridors. So when you then look at these tipping elements in the Earth system, as I said, they're all connected. If you look at the Amazon rainforest, what do we see? We see that there have been large droughts in 2005, 2010, which have led to increased fires, which have led to carbon emissions. So about 10 years of carbon storage has been lost in the 2005 and 2010 droughts. Another severe drought hit the Amazon in 2015 and 2016. So already we're seeing that climate change is driving reasonably regular droughts at 5-year intervals, which is leading to fires, leading to loss of carbon storage, leading to more pressure on the rainforest. And so direct clearing is also increasing now sharply under the Bolsonaro government. It's jumped up the last year or so. But the point is, we don't know precisely where this tipping point is going to lie. You could argue about it. Some Brazilians argue that it's farther away than we think. But I'll give the final word to my colleague, Carlos Nobre, a Brazilian scientist who's an expert on this. And he makes a really good point. There is no point in discovering the precise position of a tipping point by tipping it. That's the only way we're going to find out where a tipping point actually lies. This is why, going back to my earlier presentation, we move the planetary boundary upstream of where a tipping point might lie to make sure we reduce the probability that we're actually going to tip it. So that's the biophysics. That's what the Amazon looks like. So you see, from an Earth system point of view, we're dealing with a complex beast here in terms of downscaling. How are we going to deal with looking at the planetary boundary for the Amazon basin? Well, one intriguing way of looking at it is to downscale it by where are the pressures coming from. So this is some large-scale collective action approaches that have been developed by the University of Gothenburg in Sweden. And what they say is the problem now in the Amazon is that the stresses are far more powerful than the facilitators, the people who are trying to fix this problem. So what we have to do, and this is where the downscaling comes in, is we have to generate collective action at the critical points that increase the facilitators and take the pressure of the stressors away so that we flip the system to where we can sustain collective action that protects the Amazon. So the critical issue therein is, rather than downscale territorially, saying it's a Brazilian government responsibility, we need to downscale to where the important actors are. And this is where I noted earlier that businesses and corporations are important as entities in the downscaling exercise for the planetary boundaries. So who is responsible for financing Brazilian deforestation? There's some beautiful work done by some political scientists led by Victor Galatz, again from Sweden. And here are the 16 leading investors in Amazon deforestation. The two biggest ones are BlackRock and Vanguard, both based in the United States. Number 3 is the big pension fund, not the pension fund, sorry, the big Norwegian fund coming from their oil industry, offshore oil industry. But when you look at these 16, all but 5 of them are based in the United States. So if you want to put pressure on, downscale the Amazon deforestation, your locus of action is the United States, not Brazil. That's the point that's coming out of this. Intriguingly, Victor Galatz and his colleague Beatrice Krona followed this further up in trying to track the money. Where did the money come from, or came from these investors? Where did it go to? Because they're making profits out of the Brazilian Amazon. And the interesting thing, which makes it even trickier, is that the two big industries from Amazon deforestation are beef and soy. And most of the profits from these companies are going through tax havens in the Cayman Islands and the Bahamas. A little side story on this, because I was a co-author on this work. I think I was a co-author on this one or one of the other ones. But Stockholm University actually stopped publication of this part of the story because they were afraid of a massive lawsuit from these investment companies if it was published that this money was going into Caribbean tax havens. So we got a bunch of lawyers onto it. And there we go, Michelle, we really can't do without the legal profession. We got a bunch of lawyers on there who bulletproofed our paper to make sure that we couldn't get sued by the investment companies. When we actually published, which we did in Nature, Ecology, and Evolution, tracking the money back from the Amazon deforestation profits through tax havens. So these companies not only were directly financing the deforestation of the Amazon, they weren't even paying the taxes on the profits they were making. So that leads to the questions for when you downscale is who really is responsible here? What can we downscale? I think we have to learn how to downscale these complex systems, but we need to do it in a sophisticated way. So we actually track who's responsible for transgressing these planetary boundaries, and how can we actually get at trying to solve this issue. So in a way it becomes more fun, I think, because it gets you into some really intriguing situations. It really brings the legal side of things in really fast when you determine what can you do in this sort of situation? What is the role of globalization? And how do you attack these entities that work across global boundaries, across legal systems, but using international finance to drive what they're doing? Hugely interesting case study. Holger may have more to say about this, but I really think there's a really great opportunities for some research on how do we actually get at these more complex issues. So here's the issue. These PBs are really, they're a nice set of 9 of them. We can draw them in a nice, neat radar diagram, but really we're operating in a highly connected, highly nonlinear human world that is now imprinting enormously on a highly interconnected biospheric planet. And this is really what we're going to start untangling. I think we can do it because I think we can identify who the major players are in all this and try to get at how we deal with their role in transgressing these boundaries. So I want to switch gears now at the last bit of this talk and talk about a different type of scaling, which I think is upscaling, which is more of a thinking, conceptual idea. And I want to start with Kate Raworth. She's been mentioned before. She's the genius behind the donut economics, which I think is one of the most innovative approaches I've seen in a long time. What Kate is saying is that we need to develop economies that look like a donut. So these economies need to deliver human well-being. And she talks about a social foundation of, obviously we need healthy food, plentiful clean water, enough income to live comfortably, health, gender equality, social equality, jobs, resilience, and so on. What it takes to have a well-functioning human society. There are countries that are aiming for this. The three I can think of are Costa Rica, Bhutan, and New Zealand, who are looking at well-being economies that actually focus not on growth for growth's sake, but on this. But Kate then says, we need to adopt an environmental ceiling because we can't do this with neglecting the fact that we live on a finite planet and we have to keep a well-functioning Earth system as well as a well-functioning human system. So the ceiling, the environmental ceiling is, as you can look at the shape of this, these are the 9 planetary boundaries. So she's adopted those as the guidance system for saying, what is the limits that we must respect for not transgressing the integrity of the entire Earth system. So this is the sweet spot for humanity, a well-functioning human society living within the limits of our home planet, donut economics, or as she says, a safe and just space for humanity. And she's getting a fair bit of traction around the world. If you read her book, she has 7 major points. I pulled out 3 of them that I think are really important. One is we need systems thinking. Neoliberal economics is not systems thinking, it's linear thinking. We need systems thinking or dynamic complexity. We need equity. We talked about that in the first session. The economy needs to be distributive by design. You don't have to rely on governments after the fact to redistribute income. The whole economy should do it by itself. And it needs to be regenerative, not exploitative in terms of the biosphere. So these are key components of donut economics. And this is Kate's view of how corporations ought to operate in a boardroom in the future, is they need to look at their role in creating this sort of economic system. The other one you're going to hear about from Paulo Marguelis is one of the most brilliant legal innovations I've come across in my career. And this is the Common Home for Humanity, a blueprint for global governance. What if we thought of the Earth as an immense condominium? Well, what is Paulo talking about? Well, I happen to live in a condominium in Canberra. I live in an apartment house in the middle of the city. Now, my wife and I own a flat. We can do a fair bit to that flat. We can put in our own furniture. We can paint the walls. We can do that. But there is some common property. There is an electrical system, there is a plumbing system, there are lifts, there are things that belong to a well-functioning building. Nobody owns them. There's a body corporate, a group of people, of owners of the individual units who act as a committee who look after the building as a whole. Can we think of the Earth as a condominium? We have nation states, and we can do some things to Australia, we do a lot to it, and other countries can do their thing. But we have a common building that we need to keep in a well-functioning state. That is the Earth system. So that's Paulo's insight, which I think is really brilliant. Or he puts it this way. What does the legal system do now? Well, on the left there, you see planet Earth. The legal system looks at it as 500 million square kilometers of territory, land and ocean. And we divide it up. We put borders in, we put economic zones in the ocean, and so on. But he says, what we really need is a new object of international law, the Earth system, the circulation systems, and so on, that together make a single complex system that has its own properties. And that's our home. The Earth system is our home as much as the Earth is our home. So I think his real insight was to say, we need legal recognition of the Earth system as humanity's common home. Or to put it in the modern digital world, we need to recognize and protect the software as much as we recognize the hardware. So these are some good analogies of what Paulo is trying to do. So this is what we're trying to look at the Earth, not just as land that can be divvied up, but as these beautiful circulation systems around the planet that actually make it habitable for us humans and the rest of life on the planet. And we must also look at the biosphere as being part of this system that itself plays a strong regulating role in these patterns of circulation. So he's going to talk more about this, but just as a teaser, here is his architecture, is that somehow you need a governance body at the global level for the safe operating space. You need some scientific input. You need a scientific commission here that helps support this, and you need the planetary boundaries as a scientific framework. But then you need to, first of all, you need to legally recognize a safe operating space, a well-functioning Earth system. And here's where the downscaling and application occurs. You need some sort of accounting framework. And again, his really important insight is, right now you only make money by exploiting it. You only make money by cutting down the trees in the Amazon and putting in a soya plantation. But we need to make a system, an accounting system, that you get credits for restoring and protecting the Earth system. As much credits or more credits than you do for exploiting it. And that's the job of this governance body, is to say, how does this accounting system, how can we structure it so that it maintains a safe operating space? And you need a governance framework to manage this whole system. So that's his idea. I'm going to conclude then by looking at this a little bit more philosophically, that I think to make any of this work on a legal sense or on an economic sense or on a scientific sense, we actually have to have a different value system and a different philosophy from the one that's driving our present economic and governance systems. And that gets back to this idea of the fact that we've left the Holocene, we are in the Anthropocene. And so people in the humanities and philosophy are really important in helping us develop these guidance systems. And here I just want to quote from a colleague, Dipesh Chakrabarty from the University of Chicago, who also has some association with the ANU here in Canberra. And he says, contemporary society is based on a homocentric approach, a human-centric approach. He said, but the Anthropocene demands a zoocentric, a life-centric approach. So that's the fundamental change in philosophy we need to have. And he has a wonderful phrase. He says, right now we're dominated by departmental thinking. Go to any university and you know how we suffer from departmental thinking. But I love this term he uses. We need epochal consciousness. The fact that we are in a new epoch and this demands a completely new way of thinking. And my colleague Carl Folke from Stockholm says, really our fundamental goal is to reconnect to the biosphere. Our whole technology and economy is isolating us increasingly from the biosphere. We need to reconnect from the biosphere. And that's why I think we need to learn to respect and learn from indigenous cultures around the world. They were connected to the biosphere. They continue to attempt to be connected to the biosphere, despite the fact the things that our dominant cultures are doing to the biosphere. So I'll just summarize to say, there are a lot of challenges to applying the planetary boundaries. So there's an enormous amount we can do in a practical sense, that we can do in a legal sense, that we can do in a governance sense, that we can do in developing new legal frameworks for how we manage ourselves and our relationship to the planet. But ultimately, all of this has to be driven by changing the way we think about who we are and the planet we live on. And that's what I call, we need to build planetary consciousness. That needs to be the underpinning of how we approach the more practical legal questions and so on. This last image actually comes from Paulo. This is his view of how we need to sit back and rethink how we relate to the planet that we evolved into and we are part of. So I think I've used my half hour now. So I'll stop there and hopefully we can have another rich discussion like we had last time. So thanks very much again for your attention. I'll leave this on now this time in case we want to go back to it.
Sure. Thank you so much, Will. And again, some Daggy air clapping from me and anyone else who wants to join. Thank you so much. Very rich and very interesting and challenging. We have a couple of questions coming through and people do pop your questions into the little chat space. Tim has asked a question that I was going to ask too. It would be great to get your reference list for these talks. Would that be possible? You've noted them in your slides, but I don't know if you've actually got a reference list that I could.
Good question. I haven't put it together. So a lot of these references. I want to
give you more work.
That's right. I'll try to get at it. It's a good question. A lot of them are actually references to papers or documents as well as to talks. So in fact, most of them are references to papers. I'll see if I can go back and do that.
Only if you have the time, but I must say, if you can share them, we'll be putting them on the website for Greenprints, which is going to become our little Aussie-based home for anything to do with planetary boundaries and a range of other wonderful methods for looking at ecological limits. So thank you, Will. Now, Tim's question is, regenerative economics and design, etc., as conceptual frameworks have not been so explicit in social ecological thinking that he has found. Is there much work in developing the regenerative sense at present in organisations such as the Stockholm Resilience Centre?
Yes, there have in places like that for sure. Probably less so in other places, but there's a lot of thinking amongst that group and network. There are other organizations around Earth that are associated with the SRC that do that sort of thinking. Kate obviously has done a lot of work and she's getting some traction. In fact, just recently she's been contracted by the city of Amsterdam to try to apply donut economics, and she's got a group working hard on that. I think that's going to be a really interesting case study, hopefully developing some principles that can be scaled and replicated in other areas.
Mm. And I might follow that up to Tim. Ayla is connecting into the regenerative roadmap initiative, which is strangely coming out of the Commonwealth Secretariat, but places like Costa Rica, New Zealand, and a lot of the progressive places that are linked. There's these common linkages now between the Wellbeing Economy Alliance folks. There's a whole body of thinking there. The regenerative road mapping space is very interesting, and we've been chatting here at Ayla with folks in Costa Rica and New Zealand and other places, seeing how they are connecting regenerative economies, regenerative agriculture to the transformation required to live within our limits. So there seems to be this lovely emergence. And just another note, we will be having some folks from the Donut Economics group who work with Kate, the Donut Economics Lab, they call it, chatting as part of this series in October. They all said no one can speak to us officially until then. They've been locked away by Kate to work on a whole bunch of toolkits and information sets. So I'm actually really happy to know that they're on their way. So, yeah.
Before you go, just one more contact on the regenerative idea.
Yes.
World Vision is very interested in promoting regenerative agriculture.
Oh, I did not know that.
So it would be worth contacting World Vision about their regenerative agriculture ideas. So I'm doing a wee bit with them on a Zoom meeting, talking a little bit about the role of regenerating the biosphere, mainly through new agricultural practices, and how that also addresses climate change and equity issues as well.
Yes. Thank you, Will. And I know that you're a busy human, but if at any time you do interact with other folks in Australia around it, please bring them to us. We're going to be building the website as a place for, exactly as you said, bridging all the great ideas, but doing our own great ideas on the ground to bring it all together. And I know from the chatting with Edward and others in the regeneration roadmap folks in Costa Rica, they have singularly honed in on agricultural practices to start with because it links to planetary boundaries. So yeah, very cool. Sorry, I'll just backtrack. Rosie has asked a question that may or may not depress you. Personally, Will, do you think humans have what it takes to turn our situation around and head back to the Holocene?
All right, first of all, we're not going back to the Holocene.
Where are we going, Will? Where are we going?
We're on a one-way street, and that is you really don't go back in geological time. The reason I say that is one of the two core boundaries is biosphere integrity, and I think although we can regenerate biosphere, it's going to look different from the Holocene biosphere. I think if we stabilize the climate, it's going to be well above a Holocene climate. So the way I like to say is we're not going to go back to the Holocene. That's in our rear vision mirror. We can get to what we call stabilized Earth. If you remember that little landscape diagram I put in my first presentation, I had this thing called stabilized Earth. That's our goal. And I sometimes say it's a Holocene-like or interglacial-like state, but it is a little bit supercharged in terms of temperature. So in other words, even 1.5 is well beyond anything we've seen in the Holocene. So that's more of a technical thing, but I'm pretty careful not to step on my geological colleagues' feet by going back to the Holocene. We're not going to do that. But there's a huge difference between stabilized Earth and hothouse Earth, and that's what we want to avoid. So we definitely want to get to stabilized Earth, and I think in addition to stabilizing the energy balance that, in the lower atmosphere, which we have to do, we have to regenerate a lot of the biosphere. That's absolutely central to getting to stabilized Earth.
And just another interesting point, Glenn Albrecht, who's quite the legend in Australia for framing words and language, and actually termed or coined the term solastasia, the kind of the loss and longing for a time when our environment around us was more intact, has started talking about the symbiocene, which is he wants to get out of the Anthropocene as quickly as possible and into a zone of time where humans acknowledge our complete interdependence. And perhaps, as you said, Will, that initial diagram showing that we actually have to manage our planetary boundaries to put planet Earth into that safe, stable place. So Rosie, maybe you can cling to the idea of a symbiocene kind of future structure. There's been a couple of comments, lots of enthusiasm for your reference list. I don't know if there's any more technical questions at the moment. Do have a think, folks. It's not very often. Oh, there's a couple more coming in. Oh, Margot's asked a good question, actually. It's a short one too. I like them. Margot, the concept of overpopulation seems to be missing in the donut, or is it represented somehow?
You have to ask Kate about that. I think it's implicitly in there that you can't reach all those social goals with having an ever-increasing population. The interesting thing about population is we did a little exercise on the Great Acceleration graphs. That is, these enormous sweep-ups of human activity, the graphs going up and up and up from about 1950. And we decided to look at this issue of population. And we took a very simple identity equation that's due to John Holdren and Paul Ehrlich called the IPAT, which many of you know.
Yes.
That the impact equals some aggregation of population, affluence, and technology. So we made a box, a three-sided box, where the three axes were population, affluence in terms of GDP, and technology, and the indicator we used for that were patents, patent applications, and so on. Anyway, so we made this box. And so what we found out was that the dominant axis was actually consumption. So it was not population. So, and the problem is this, is that 75% of the world's GDP, this was I think in 2010, was due to 18 or 19% of the population. So over 80% of the population, if we all live like that, would not have thrown the Earth into the Anthropocene. Having said that, as we globalize, more and more the human population is adopting Western-style economies and consumption patterns. So then population does become an issue. I don't want to downplay population entirely, but it's far more sophisticated than saying it's just a population, it's just a problem of overpopulation. No, it's mainly a problem of overconsumption and inappropriate consumption. That's the number one problem. Population comes in, and so do technologies as well. But it's the overall consumption amounts and patterns which are still the most important factor.
Will, can you remind me, I talk about iPad a lot, but I can't remember who the original author was. I might pop it in here in the chat in case folks want to look it up. Was it, who was it? Do you remember?
Sorry, the author for
iPad or some information?
Yeah. That was John Holdren and Paul Ehrlich. So John Holdren was Barack Obama's science advisor, but he and Ehrlich were colleagues. I think at Stanford University in America, one of the California universities. I'm pretty sure it was Holdren and Ehrlich who came up with that.
Excellent, thank you. Yeah, and Paul Ehrlich is a little famous for writing The Population Bomb in 1968. And
yes, indeed.
Since then. So, and speaking of the past a little bit, great question from Ruth, which has come in more as in the private chat. She's very interested. Ruth works with us in AILA, and it's a great question. Planetary Boundaries has really, I guess, emerged in the 21st century. And her question is, how do you see it as connecting to or strengthening or differing from mechanisms like the global footprint approach or other ways that are trying to look at helping people understand their impact on planet Earth, more at a local scale? And have you thought about how all those other tools fit together, or that's not been a concern?
Yeah, I think the difference is Planetary Boundary starts from viewing the Earth system as a single complex system that exists in well-defined states with transitions in between them. So the global footprint is interesting, but it's just measuring human pressure. It doesn't really say, well, at 1.8, do you flip the Earth system, or at 2.1 global Earths? How many global Earths, how resilient is the Earth system? So we're trying to take a deeper dive into how the Earth system itself operates, and what are the limits based on the planetary structure and functioning. In other words, how far can you push it before you really flip it out of a Holocene state? Now, obviously, we're looking in the rearview mirror there because we are out of a Holocene state, and that's what the Anthropocene and the Anthropocene Working Group is doing, is actually really defining that. But it's very consistent with the Planetary Boundaries framework, because our two core boundaries, and if we use novel entities as a third, all three of those have been transgressed. We're beyond the boundary, which means we're beyond a Holocene-like state. And that's exactly what an enormous amount of data, including stratigraphic data from the geologists, they're all saying the same thing. The Holocene's in the rearview mirror, is what we're all saying. But what the Planetary Boundaries is trying to say is, how can we get into a stabilized Earth state, which at least might be somewhat similar to an interglacial? And that requires us to really try to get back within the safe operating space by removing CO2, regenerating the biosphere, and so on. Remember that the planetary boundary for CO2 is 350 parts per million. That is a climate that is hotter than any of the interglacials over the last 1.2 million years. So it's not the Holocene, but it would be stable against a much hotter Earth. Mm. So that's the difference, is we're an Earth system-oriented framework.
Yep. Thank you, Will. No, that's excellent. Certainly the work we're doing in AILA is grappling with all the different tools and approaches out there so that folks at the local level can do the right thing, but also connect upscaling to the downscaling that's happening with planetary. Yeah. One question I had, Will, if we could go back to the SDGs, the Sustainable Development Goals. Yes. You mentioned that there was a lot of input from the planetary boundaries concepts into the SDG, which is actually really great to know. Would you point us to, were you involved in any of literature around that can tell the story of how that was connecting or trying to connect, or is there anything that some of us could read a bit about that?
Not that I know of. My information on that's firsthand from Johan Rockström, because I work a lot with Johan. So he and some of his team, then at the SRC, he's now at Potsdam. When he was at the SRC, they were working through the Swedish government in the SDG formulation in the UN. So I think there was a lot of toing and froing through committees, feeding in information from the planetary boundaries and so on. I think there the idea was that the SDGs had their own framework, so they weren't going to just take the 9 planetary boundaries. They were going to say, these 2 planetary boundaries affect this SDG. These 3 SDGs link to this planetary boundary. So it's not a one-to-one correspondence, a bit more complex than that. And other factors came into the SDGs as well. So it's not a pure mapping. What I'm saying is there is an influence of the planetary boundaries in the SDG framework.
Now that's actually good to know, Will, because myself and many others were concerned about the growth paradigm continuing. So even knowing that there was some conversation between the development is actually kind of helpful to know. So thank you. Got a couple of questions coming in. This sounds like a big question, but Cameron has asked, and I'm sorry if you can hear thumping in the background. It's actually my dogs have decided to have a party on my timber floors. I do apologise. The joys of working from home. The biosphere is perturbing my homosphere. Cameron has asked, he said, thank you for an amazing class. I'll definitely be rewatching. I was wondering if you could summarise a list of the most common critiques of planetary boundaries thinking and how you respond to them. Question, but even a small snippet? Yeah,
there are some criticisms. One of the first ones was, and it was actually, I think, a deliberate misinterpretation of them, was to say, not all of these processes you're talking about have thresholds. So why are you putting a boundary on it? And then equating the boundary with a threshold. And I showed you in the first presentation, I think, that no, that's not the case. And in fact, we really put an extremely sharp rebuke back in the literature, pointing out that in the paper they criticized, we actually said explicitly, no, not every boundary process has a threshold, and no, the boundary is not at the location of the threshold. Then there are quite a few critiques, mainly coming from my ex-homeland on the other side of the Pacific, who do not like the idea of boundaries or limits of any kind, and saying, no, this is all a bunch of rubbish. The Earth is far more resilient than we think. We can keep on doing what we want to do. And you can sort of see that in the views of their present president at the moment. And we had to kindly point out that the geological record shows that that isn't the case, that the Earth system does exist in different states with transitions between them. And just because it's only been geological forces in the past, which actually is not true, which is the point they were making, there have been biological changes that have driven changes in the Earth system in the past as well. So those are some of the main criticisms. Apart from a really common one is, this is too impractical. We'll never, get this to work, et cetera, et cetera.
Thank you, Will. I just had to turf my dogs outside so that they weren't disrupting us. There was another comment. Well, actually, there was an important question, but I think we've touched on it. How do we get all this incredible work onto the government's desks? Will, is there a group within the various Earth system governance researching spaces that are looking at how you kind of lobby or communicate core elements to national governments, or should we all kind of sit together as groups in Australia and think about how we communicate the science of this into our own communities and politicians?
Really good question. There is a project within the Future Earth program called Earth System Governance. That's well connected around the planet. They're the ones who are thinking exactly in the way you describe. The chair of that is Frank Bierman, Bierman. You may have heard of Frank Bierman. He's located in Netherlands, I think at Utrecht, but you can Google him. I'm pretty sure he's at Utrecht. He used to be at Amsterdam, but he's moved. And he heads up the network of Earth system governance around the planet. It would really be great to get into that network, because
I would love to.
They are thinking about exactly those questions. How do you change governance, not governments, governance systems to take into account planetary boundaries and other frameworks for looking at the global system?
Thank you, Will. And if I can push our friendship the same way that you introduced me to Holger and a few other folks like Paolo, if you were able to introduce me to Frank, that would be quite the honor of his material. And many of us in Australia would love to connect with those groups. Certainly Ayla is preparing itself for a decade-long effort into translating it onto the ground, but also advocating for systems change through the political processes.
Right.
Thank you. Good question. Andrew has asked, excuse me, he said, I'm an artist connecting personal experience with Earth systems. Ooh. Are you aware of other artists working with Earth system science or scientists to imagine these ideas in an artistic context?
Yeah, I can't, off the top of my head, I can't tell you precisely, but yes, I bump into this quite a bit. In fact, one of the early meetings around the idea of the Anthropocene was run by a big house of culture and art in Berlin. In fact, the translation from the German is the House of Cultures of the World. And it had a lot of artistic impressions of the Anthropocene, which of course is a hot topic that's obviously related to the planetary boundaries. The whole idea of the planetary boundaries is to steer the trajectory of the Anthropocene into stabilized Earth. But there's been an enormous amount of really, really clever stuff done by artists, including visual arts, poetry, music, and so on. I think more so than the planetary boundaries, if you start Googling Anthropocene and look at some of the interesting artistic interpretations of that proposed new geological epoch, you can get into it there. It's a hugely interesting topic, and I think one of the wonderful things about being part of the Anthropocene Working Group, which is chaired by stratigraphers. In fact, the chair is Jan Zalasevich from Leicester. He's completely open-minded and really invites a lot of humanities scholars and artists to contribute to their view of the Anthropocene to help us form the more scientific rationale for getting this formalized in the geological timescale. That process is underway, by the way.
Wonderful. And I guess it also links, you were saying towards the end of your talk, Will, the change of consciousness, the change of mind. Again, that links, Ayla's initial work was always about raising awareness of the human-centeredness of Western society particularly, but looking at an earth ethic and an earth-centered way of being. So that sounds terrific. And Andrew, Helen has commented also, look into climb art. She's written the group down there. And Ayla has an Earth Arts program. Every 2 years, we normally have a particular theme. This year in October, we'll have a whole range of online and in-person events in Brisbane and in other cities in Australia. It's called the Voice of Nature, and it connects to the bioregions and a whole bunch of ideas around standing, rights of nature. It's part of the Rights of Nature Week. But if you and others were to come to us and say, how about you gear up and do some earth system and art, then that would be great. Okay, I've got a few other comments here. Oh, we've got lots of artists. We've got Judith and Jared are saying, I'm part of a Dance of Universal Peace network and a Sacred Circle Dance network. And our dancers in philosophy dream these connections and this consciousness. Excellent. Lisa Roberts is working as an artist in residence at the science faculty at UNSW. She and others are preparing a presentation for the IPCC report. Euphoria Superba. How cool. There's a whole bunch of comments coming in. Okay, here's an actual question.
Right.
Aha. Alice asks good questions about communicating science. Drawing science and policy together can be very challenging. She says, you are a rare and inspiring example of effective communication across the disciplines, Will. Are there any risks or problems you see in the way that Earth system science is used in the humanities and social sciences? Any pitfalls to avoid?
Not really. It's such a new concept that I'm struggling, spending most of my time trying to get my fellow natural scientists who come from disciplines to understand that Earth system science is not a discipline. It's a trans-discipline. It's a new way of thinking. So I'm struggling a bit with that. I do try to interact with humanities scholars and social scientists as much as I can. I find that really interesting and rewarding. And I probably learn far more than I can contribute. But one of the things I do find, particularly with humanities scholars and artists, is they're much more adept at jumping out of any disciplinary boundaries and just thinking more broadly. And I think that's a really good thing. And that's why I think engaging the humanities in particular on the whole question of the Anthropocene, which of course is related to planetary boundaries, is really important. So yeah, I think it's a big issue.
Wonderful. Okay, we're coming up to 4:25, 4:30, and we've had Will for 2.5 hours. So I think we might start to think about wrapping up and releasing him back into the wild so that he can go forth and share Earth system science love with other people. But I might do some slow closing remarks for a few minutes. So if you've got any final questions, please do jump in and grab Will while you've got him. But firstly, Will, I really want to thank you. Both yesterday and today has just been fantastic. We've really enjoyed it, and we will be annoying you as Ayla does at least once a year, but probably several times a year now for indefinitely as we build and hopefully become part of the global movement to get more people thinking about planetary boundaries. So perhaps with everyone who wants to either press the magic clap button or do an air clap like I do, say thank you so much, Will, for your time. Yay, thank you. See the little claps?
Yeah.
Now,
well,
someone, yeah.
Sorry, go ahead. You have another question?
Oh, well, someone actually asked a nice question. What's your actual personal mission? I think that's really nice. What's your personal drive and mission, Will? Yeah.
I would at least like to play some role in changing the way we think and operate our societies. And obviously a personal interest, I've got a daughter in her 30s down in Melbourne, and she has an unenviable job now. She's on the staff of the Deputy Premier. So she's up to her ears in the COVID crisis in Victoria at the moment. But she's done a PhD on animal ethics and animal rights, and more broadly, the rights of the natural world. So from a philosophy point of view, which links in quite nicely to legal aspects, to Earth system science and so on. So I guess my mission in life is to try to do whatever I can so that she has a better planet, a healthier planet, better functioning planet to live on when she gets to be my age, assuming that the planet's going to be in good nick 40 or 50 years down the track. So yeah, so that's what that's what I try to do. That's what keeps me going. But I think talking to people like you, interacting with my colleagues around the world, it keeps you hopeful. And for those who want hope, I have a message. Nobody's going to give you hope, but you can generate it by acting and talking and interacting and trying to make the world a better place in your own way. That's how you create hope. And the last thing I'll say is that it's been a busy day. I've had 2 interactions with the legal side of things this morning, and that's trying to stop coal mines and gas fields in Australia, which I'm spending more of my time providing evidence to do that. So it's been a long day. So I'll leave you with one motto. From an Earth system science point of view, at the end of the day, there's nothing better than to think globally and drink locally.
It sounds like Will really needs a little drink, or at least a big drink. But thank you for sharing that, Will. I'm sure that everyone will have much to think about and to be inspired by. And personally, I think that your contribution to changing the whole way that humans see the world is already well established, and you can just grow it now, but you've done a great job. So look, lovely. There's some lovely thank yous and comments coming through. Thanks, everyone. I'm so glad that you've all enjoyed it and participated. And Will, thank you again. If you have any breath in your body in the next month and you'd like to share the reading list, I think this group and our website would love to promote that. And I might be back in touch with you in a month or so to annoy you and invite you to other things as we try to get a lot more of the planetary boundaries and Earth system science discussions going in Australia. So final clap and we'll hang up. But thank you so much, everybody.